Now today in this lecture I am going to explain about the Vernier calipers and its experiment we will do. This will be the first experiment on Vernier calipers. Though already you have done it in the class 9th. So see here, you can see here this is a just like a ordinary meter scale which is graduated in millimeters and centimeters. In the lower side, if you see, it is graduated in millimeters and centimeters. 8 centimeter, 9 centimeter, 10 centimeter. In between two consecutive centimeters, there are the 10 divisions of 1 mm. Means 1 centimeter equals to 10 mm. It is clear. Now, the smallest measurement which can be taken accurately by it, that is 1 mm. You can see here already I have marked here in between 9 to 9.1. This is 1 mm. It is clear. This length will be 1 mm. In between two consecutive divisions, the distance will be equal to 1 mm. This distance can be recorded accurately by this. If the length is smaller than this length, then that cannot be recorded by it. So what will be its least count? What is the least count? It is the minimum measurement which can be taken by an instrument accurately. For example, in wall clock, what is the minimum time which it can record accurately? That is 1 second. So the least count of wall clock is 1 second. Similarly, here minimum length which it can measure accurately, that is 1 mm. It is clear. Means least count will be 0.1 centimeter. Of ordinary scale, the least count is 0.1 centimeter. But suppose if there is any length which is smaller than 0.1 mm, suppose it is 0.08 centimeter, then how will you measure it? So, for measuring such lengths which are smaller than 0.1 centimeter, we will use another scale that is called the Vernier scale. It's clear. And this combo of Vernier and main scale is called the Vernier calipers. For measuring the lengths which are smaller than 1 mm, we will use a scale which is called the Vernier scale. And the combo of this Vernier and main scale is called the Vernier calipers, which I am going to explain you today. It's clear. You can see here in the Vernier calipers there is an ordinary scale which is called the main scale. There is an ordinary scale which is called the main scale. You can see here. It's clear. This is the ordinary scale. It's clear. This ordinary scale is graduated in millimeters and centimeters. It is graduated in millimeters and centimeters. You can see here. Now there is another scale which is called the Vernier scale and which can slide over the main scale. मतलब क्या है, हम इस वर्नियर स्केल को इस मेन स्केल के ऊपर इधर उधर खिसका सकते हैं, इधर उधर खिसका सकते हैं. वर्नियर स्केल को मेन स्केल के ऊपर मूव कराया जा सकता है. और जब हमको किसी पॉइंट पर इसको रखना है, देन वी कैन यूज दिस बाइंडिंग स्क्रू टू टाइट इट, टू fix it rigidly over the main scale. To fix it rigidly over the main scale, we use this screw. It's clear. So you can see here. So this is the main scale here. This is the main scale which is graduated in millimeters and centimeter, and this is the Vernier scale which can be slided over the main scale. Now what is the advantage of the main scale? Here you can see in main scale there are some fixed number of divisions. There are some fixed number of divisions in the Vernier scale. You can see here. This is there are some fixed number of divisions. If you count here, then you will find that there are 10 divisions, 11 lines and 10 divisions. You can count here. This is the 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. These are the 11 lines, but the divisions are 10. It's clear. Now, with the help of by using this Vernier scale, we can measure the lengths which are smaller than 1 mm. The lengths which are smaller than 1 mm can be measured with the help of the Vernier scale by using Vernier scale. Now see here, here these are the lower gauge. You can see here these are the lower gauge, and these are also called the external gauge, which are used for measuring the external diameter, external length. For example, there is a spherical bulb, then its external diameter can be measured with the help of this. These jaws are called the upper jaws, and with the help of this we can measure the internal diameter of a beaker. Internal diameter of a beaker. And there is a strip, metallic strip here, which is attached with the वर्नियर स्केल. वर्नियर स्केल में पीछे क्या है, ये एक स्ट्रिप अटैच है, मेटेलिक स्ट्रिप अटैच है. With the help of this we can measure the depth of any vessel. You can see here, if I show you here, this is here, this is measuring the, these lower jaws are used for measuring the external diameter, external length, while the upper jaws are used for measuring the, you can see, upper jaws are used for measuring the internal diameter of a beaker. You can see here, with the help of the upper jaws, internal diameter is measured, and then with the help of the metallic strip we can measure the depth of the beaker, depth of the beaker. So this is the use. So you can see here, we can see here this. Now here there are two fixed jaws and two movable jaws. You can see, if you see here, let me erase it. This. Now, if we see, these jaws are fixed jaws, which are fixed with the main scale, while these one are movable jaws, which can move over the main scale when the वर्नियर स्केल इज मूव्ड ओवर द मेन स्केल. मतलब ये दोनों जाज क्या कर सकते हैं, ये मूव कर सकते हैं. इट्स क्लियर. जब वर्नियर स्केल को मेन स्केल के ऊपर चलाएंगे दे विल मूव. नाउ सी हियर, व्हाट इज द प्रिंसिपल ऑफ वर्नियर. Principle of Vernier, if there are n divisions on the Vernier scale, it was invented by the Pierre Vernier. If there are n divisions on the Vernier, then they will be equal to n minus 1 divisions of main scale. Vernier calipers is constructed in such a way that if there are n divisions on the Vernier, then they will be equal to n minus 1 divisions of main scale. It's clear. Now if you join both the jaws of Vernier calipers, that is the fixed jaw and movable jaw, अगर हम दोनों jaws को आपस में मिला दें, what will you find? You will find that the, here you will notice that the zero of Vernier, this is the zero of main scale, and this is the zero of Vernier scale. They are along the same line. They are along the same line. मतलब जो वर्नियर का जीरो है वो मेन के जीरो से कोइंसाइड कर रहा है. अब वर्नियर का 10th डिवीजन देखें. वर्नियर का 10th डिवीजन इज कोइंसाइडिंग विद द 9th डिवीजन ऑफ द मेन स्केल. It is clear. Means here 10 Vernier scale division is equal to 9 main scale division. Means Vernier calipers is constructed in such a way that if there are n divisions on the Vernier scale, then they will be equal to n minus 1 divisions of main scale. Here there are how many divisions on Vernier? There are 10 divisions on the Vernier. They will be equal to how many divisions of main scale? 10 minus 1, that is 9 main scale division. Suppose if in Vernier there are 25 divisions, then they will be equal to 24 divisions of main scale. If there are 50 divisions on the Vernier, then they will be equal to 49 divisions of main scale. But here there are 10, so I will explain for this. So 10 Vernier scale division equals to 9 main scale division. Now what is the value of each division of main scale? So already I have told that the main scale is graduated in millimeters and centimeter. What is the value of length of each division of main scale? That is 1 mm. Means one main scale division is 1 mm. So what will be the length of 9 main scale division? That will be equal to 9 mm. Means you can say, in the other words, you can say that 10 Vernier scale division की लेंथ किसके बराबर है? 9 mm के बराबर है. वर्नियर के 10 डिविजन्स की लेंथ कितने के बराबर है? 9 mm के इक्वल है. सो व्हाट विल बी द वर्नियर के एक डिवीजन की लेंथ? सो 1 Vernier scale division equals to 9/10. From here you can see that 1 Vernier scale division equals to 9/10, that is 0.9 mm. 0.9 mm. It's clear. Means we can see that one main scale division is 1 mm. One Vernier scale division is 0.9 mm. One main scale division, its length is 1 mm, while one Vernier scale division, that is 0.9 mm. So whose one division is bigger? So main scale division. Main scale is bigger. It is already clear from the principle. वर्नियर के n डिविजन्स की लेंथ मेन के n-1 डिवीजन के बराबर है. इसका मीनिंग ये है that main scale division is bigger in length, Vernier scale division is smaller in length. It's clear. Now you can see here there is how will you calculate the least count. So about least count already I have told, but how will you calculate it? So there are two formulae. In case of the Vernier calipers, there are two formulae. One is the 1 main scale division minus 1 Vernier scale division. 1 main scale division minus 1 Vernier, that is 1 mm minus 0.9 mm. 1 minus 0.9, that is 0.1 mm. But we write this in centimeter, 0.01 centimeter. हम लोग इस चीज़ को याद रखेंगे. वर्नियर कैलिपर्स में सभी कैलकुलेशंस हम सेंटीमीटर में करते हैं, जबकि स्क्रू गेज में यही सभी कैलकुलेशंस मिलीमीटर में करेंगे. इट्स क्लियर. दिस इज ओनली ए कन्वेंशन, अदरवाइज वी कैन डू इन मिलीमीटर आल्सो. इट इज क्लियर. सो लीस्ट काउंट इक्वल्स टू 1 MSD minus 1 VSD. This is one formula. There is another formula. Least count equals to length of 1 main scale division upon total number of divisions on Vernier scale. So length of 1 MSD 1 mm upon 10, that is 0.1 mm. That is 0.01 centimeter. It's clear. Now see here. How will you find this formula? This is the formula of least count. 1 MST minus 1 VHT, this is the formula of least count. Now, how will you reach over this formula? Now that I am going to explain. As we know that, what is the principle of Vernier? N Vernier scale division is equal to N minus 1 main scale division. It is clear. N Vernier scale division is equals to N minus 1 main scale division. If we assume that the length of one main scale division is equal to x, so what will be the length of n वर्नियर स्केल डिवीजन? तो देख लो, n वर्नियर स्केल डिवीजन की लेंथ क्या होगी? मेन स्केल के n माइनस 1 डिवीजन के बराबर होगी। मेन स्केल के एक डिवीजन की लेंथ x है, तो n माइनस 1 की कितनी होगी? इतनी। तो क्या मिल गया हमको? n वर्नियर स्केल डिवीजन इज इक्वल टू n minus 1 into x. They will have this length. So what will be of length of one Vernier scale division? One Vernier scale division n minus 1 into x upon n means this. So what is the least count? 1 MST minus 1 VHT. You substitute here. Simplify. When you will simplify, what will you get? Nx minus nx plus 1. That is, this and this cancel, x upon n. What is x? X is the length of one main scale division. What is n? Number of divisions on Vernier. Number of divisions on Vernier. So this is the another formula of least count. Length of one main scale division upon total number of divisions on Vernier. Now after this already I have explained you, least count. Now after this I will explain about the zero error. It's clear. So see here, you first see in this diagram. In order to determine whether there is some error in the Vernier calipers or not, what will you do? First of all, you will join both the jaws of Vernier calipers. First of all, you join both the jaws of Vernier calipers. Here both jaws of Vernier calipers are joined. Now if zero of Vernier is this, is coinciding with the zero of main, then it means there is no zero error. मतलब अगर वर्नियर का जीरो मेन के जीरो से कोइंसाइड कर जाए, इट मीन्स देयर इज नो जीरो एरर. मीन्स द measured value will be the true value, will be the correct value. Measured value by this will be the correct value. It's clear. If it is like this, you can see here, if on joining both the jaws of Vernier calipers, both the jaws means fixed jaw and movable jaw. फिक्स्ड जाज और मूवेबल जाज को मिलाने पर अगर वर्नियर का जीरो, लोअर वन इज द वर्नियर स्केल, अपर वन इज द मेन स्केल, वर्नियर का जीरो मेन के जीरो से कोइंसाइड कर जाए, मतलब कोई जीरो एरर नहीं है. यहाँ पर कोई भी जीरो एरर नहीं है. इट इज क्लियर. बट अगर कहीं ऐसा हो, इफ जीरो ऑफ वर्नियर इज in the right side of zero of main, means if the zero of Vernier is ahead of the zero of main, वर्नियर का जीरो मेन के जीरो के आगे है. You can see here, if the zero, if on joining both the jaws of Vernier calipers, both the jaws of Vernier calipers means the fixed jaw and the movable jaw. If zero of Vernier is lying ahead of the zero of main, this is the zero of Vernier scale, this is the zero of main scale, then it means there will be the positive zero error. It's clear. And in the positive zero error, the measured value will be more than the actual value. Measured value will be more than the actual value. How will you find how much is the positive zero error? So there is a formula of positive zero error: coinciding division into least count, this product with the plus sign, this product with the plus sign. What is the meaning of coinciding division? कोइंसाइडिंग डिवीजन का मीनिंग यहाँ पर क्या है? मीन्स वर्नियर का which division of vernier is coinciding with the any division of main scale. It's clear. So here in vernier scale you will start counting from the first line. From the first line you will start counting. दिस इज फर्स्ट लाइन इज कॉल्ड द जीरो लाइन. तो जीरो वाली तो कोइंसाइड नहीं कर रही मेन की किसी भी लाइन से. क्या ये वाली लाइन कोइंसाइड कर रही? नहीं. ये कोइंसाइड कर रही है? नहीं. ये कोइंसाइड कर रही? हाँ, ये कोइंसाइड कर रही. दिस थर्ड लाइन इज कोइंसाइडिंग. थर्ड लाइन इज कोइंसाइडिंग. If you count from beginning, then it will be fourth line. But the first line we will take the zero line. This line we will take the zero line. So 0, 1, 2, 3. Third line is coinciding. So we will say that the third division is coinciding here. Third division is coinciding. So what will be the least count here? So least count is 3, and in this vernier calipers, what was the least count? 0.01. 0.01 centimeter. That is equal to 0.03 centimeter. This with the plus sign. It is customary to assign the plus sign. Then only you can say that this is the positive zero error. It's clear. It is compulsory, customary to mention the plus sign. It's clear. So 0.03 centimeter. Now what will be the negative zero error? If on joining both the jaws of the vernier calipers, you can see here, on joining fixed jaw and movable jaw, if the zero of vernier is lying behind the zero of main scale, this is of main scale zero and this is of vernier scale, 0 is lying behind the 0 of main scale, then it means there will be the negative zero error. There will be negative zero error. And in negative zero error, measured value will be less than the actual value. How will you find the negative zero error? So first you find out the coinciding division. First you find out the coinciding division in the same way. Zero line is not coinciding, 1 not coinciding, 2 not coinciding, 3 not coinciding, fourth one is coinciding. You can see here fourth one is coinciding. Coinciding division is 4. So how will you find the negative zero error? Here there will be minus sign, number of divisions on vernier, that are 10. Coinciding division means 4 here. Coinciding division means which division on vernier is coinciding with some division of main. Into least count already we have calculated here in this case 0.01 centimeter, that is minus 0.06 centimeter. It's clear. Then after this, how will you record the reading here? So we will calculate the main scale reading. What is the main scale reading? हमको ये देखना होता है कि ऑब्जेक्ट को फिक्स करने के बाद वर्नियर का जीरो मेन के जीरो मेन स्केल में कहाँ पर लाई कर रहा है, मेन स्केल पर कहाँ पर लाई कर रहा है. It's clear. What is the position of zero of vernier scale on the main scale? That is called the main scale reading. This is written in centimeter. Then vernier scale reading will be coinciding division into least count. When the object is fixed in the vernier calipers, then you will find out the coinciding division of vernier into least count, that will be vernier scale reading. When you will add both, you will get the observed reading. Observed reading may be the length, it may be the diameter, it may be the depth, anything. So observed diameter, observed length, like that. Then correct reading will be observed reading minus zero error with sign. So positive zero error is subtracted, while when you put the negative zero error, then with this sign, this is the sign of the formula and there is the sign of the negative zero error. Both will multiply, so negative zero error is added. Negative is added, positive is subtracted. But you remember the formula in this way. You put here with sign. It is clear. Now you see here. Here this is a diagram. Here I am not showing the, after fixing the object in the vernier calipers, this is the vernier scale and this is the main scale. This is the position of the zero of vernier scale. ये वर्नियर का जीरो है. अगर इसकी पोजीशन हम देखें मेन स्केल पर कहाँ पर है, मेन स्केल पर ये कहाँ पर है, सो मेन स्केल में ये इन दो डिविजन्स के बीच में है. दिस इज 6, सो दिस इज 6.1, 6.2, 6.3. इट इज इन बिटवीन 6.3 to 6.4. So we will take the smaller one will be the main scale reading. Main scale reading will be 6.3 centimeter. Now what is the coinciding division? So you can see here this line is not coinciding. This is also not coinciding, not coinciding, not coinciding. This one is coinciding. So what will be the coinciding division? 0, 1, 2, 0, 1, 2, 3, 4. Fourth division is coinciding. So what will be the vernier scale reading? Already I have told. Coinciding division into least count, and here least count we have taken 0.01, though it may be different in others, but here I have taken this. So it will be equal to 0.04 centimeter. So what will be the observed length? Observed length is what? It is the main scale reading plus vernier scale reading. Main scale reading is 6.3, vernier is 0.04, that is 6.34 centimeter. 6.34 centimeter. Now zero error also you can calculate, but here with this diagram we are not able. Now you see here this, what will be the length here, diameter here, inner diameter. Inner diameter is measured by using the upper gauge. So what will the main scale reading? If you see here, main scale reading, this is the zero of vernier. This is the zero of vernier. This is lying in between what and what? This is lying in between 3.3 and 3.4. Between these two divisions. So main scale reading will be smaller one, 3.3 centimeter. Then you see the coinciding division. This is not coinciding, not coinciding, not coinciding, not coinciding. This one is coinciding. Means 0 is not coinciding. 1, 2, 3, 4. Coinciding division is 4. So what will be vernier scale reading? Coinciding division into least count, that is 0.04 centimeter. So when you add this and this, you will get the observed diameter. What will be observed diameter? 3.3 plus 0.04, that is 3.34 centimeter. So this is all about in this lecture. With the help of this, we will do experiment number 1.